So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, tell me in the comments where you're watching from and what time it is where you are. I love seeing the little constellation of our own human observers spread across the globe. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You hover at a distance where stars blur. Their light doesn't follow straight lines anymore. It curves, arcs, and loops back, as if space has been crumpled like paper. The technical phrase is gravitational lensing, but in this moment it feels more like you're watching the universe fold a kaleidoscope for your private viewing. Whole galaxies behind the black hole appear stretched into luminous rings called Einstein rings, ghostly halos marking where reality is bent out of shape. You don't need 3D glasses for this show. Space-time itself provides the effects. It's worth pausing here because this bending of starlight isn't just a cosmic party trick, it's evidence. In 1919, during a solar eclipse, astronomers measured how starlight passing near the sun shifted its apparent position. It was the first dramatic confirmation of Einstein's general relativity, and suddenly, space-time wasn't just a chalkboard equation, it was the scaffolding of the cosmos itself. Imagine the Victorian-era scientists squinting at faint specks of light and realizing the entire geometry of existence had just tilted. As you drift closer, the black hole's edge, the event horizon, appears smooth, almost gentle. No fireworks, no glowing signs warning "do not enter." If you weren't watching carefully, you might think you're gazing at empty space. But the light bending gives it away. Everything behind it warps, arcs, and sometimes even echoes. In deep surveys, astronomers sometimes spot 2 or 3 ghost images of the same galaxy, duplicated like mirrors in a carnival funhouse. The universe, it turns out, likes to recycle its view. Historians still argue whether Einstein himself truly believed in black holes. He worked out the equations that made them possible, sure, but he wasn't exactly thrilled about stars collapsing into points of no return. To him, they felt like unwelcome house guests in his otherwise elegant theory. Yet here you are, watching starlight perform contortions only possible if that guest actually lives here. And there are stranger whispers. In the 1970s, physicists joked about black hole hair, arguing whether these objects keep any identifying traits beyond mass, spin, and charge. The consensus slogan became, "Black holes have no hair," but fringe thinkers keep playing with the idea of extra wiggles and quantum fingerprints hiding in that darkness. Maybe the light bending carries clues we just haven't decoded, a cosmic comb-over, if you will. The deeper you gaze, the more your sense of direction wobbles. Up and down feel optional here, and distance becomes slippery. A star that looks close is actually far behind, its light bent around the edge in a perfect arc. You think about how sailors once trusted stars for navigation, steady guides stitched across the night. Here, that same guidance system collapses into a shimmering lie. Imagine Columbus trying to cross an ocean with constellations duplicated and warped like a broken GPS. Recalculating route, the cosmos whispers, except it never stops. What's most disorienting is the silence. You expect some thunderous noise, maybe a cosmic vacuum cleaner hum, but black holes are mute. Space doesn't let you hear the chaos. Instead, you get quiet light illusions, like watching fireworks through thick glass. If you wanted drama, you might feel disappointed. If you wanted a meditation exercise, congratulations. You found the universe's ultimate ASMR channel. You blink, and for a heartbeat, you wonder if the stars you're seeing are even real. The light could be 1,000,000 years old, bent, delayed, and duplicated before finally brushing against your eyes. It's a cosmic déjà vu, like meeting a stranger who swears they already know you. The black hole, without trying, becomes a kind of storyteller, retelling ancient starlight in new, distorted chapters. Your brain itches with the idea. If light can be recycled and remixed here, could information itself be hidden inside the bends? That question has haunted physicists for decades, fueling late-night arguments, chalkboard scrawls, and more coffee consumption than one galaxy should allow. Maybe these warped star images are like the corner of a hidden page in the universe's diary. If only you could flip it open. You feel a tug, not on your body yet, but on your patience. The hole beckons. Closer, it seems to whisper. Closer, if you want to see what happens to time itself. You know better than to trust a void. But then again, curiosity has dragged humans into caves, across oceans, and eventually onto the moon. What's one more step into the shadows? And as you lean closer to the rim of the darkness, you catch the faintest shimmer, a star that shouldn't exist, reflected not once but twice, as if space itself is practicing a magic trick just for you. You drift closer, drawn by a pull that isn't physical so much as mathematical, like stepping into a story problem that never quite ends. At this distance, the black hole is less a hole and more a wound stitched into the fabric of space. And if you listen carefully, not with your ears, but with that itch of curiosity, you can almost hear equations humming. Einstein's field equations, written in 1915, are deceptively short on the chalkboard. A tidy cluster of symbols, barely a sentence in mathematical grammar, yet heavy enough to bend the universe itself. They declare that mass and energy tell space-time how to curve, and curved space-time tells matter how to move. Simple, right? Except when you apply those rules to something massive collapsing under its own weight, the math spirals into a bottomless abyss. You're standing at the edge of where relativity itself shrugs and mutters, "Good luck." A fun historical fact here: the first exact solution to Einstein's equations describing a black hole came from a German physicist named Karl Schwarzschild in 1916, written while he was literally serving on the Eastern Front in World War I. Picture this: artillery shells booming, mud freezing, and this guy calmly solving the math of cosmic abysses in his spare time. Talk about escapism. But even Schwarzschild's elegant solution raised problems. His math allowed for singularities, points of infinite density where space-time curves infinitely. Infinite isn't exactly a comfortable number in physics. It's like being handed an all-you-can-eat buffet that never ends, but the food is paradoxes. Even Einstein balked at this, privately hoping nature would find a loophole to prevent such monstrosities. Spoiler, nature did not. Here's where things get deliciously weird. Relativity paints black holes as smooth, continuous geometrical creatures, no rough edges, no cracks. But quantum mechanics barges in, shouting about uncertainty and particles popping in and out of existence. Quantum rules say information must always be preserved, while relativity suggests it can be swallowed whole. The two theories, normally polite dinner guests, suddenly flip the table when discussing black holes. Historians still argue whether this clash is a bug or a feature. Some call it a crisis, physics splitting into incompatible camps at the very edge of knowledge. Others argue it's more like a cosmic hint, nudging us toward a deeper theory that hasn't been written yet. Think of it as the universe dangling a locked treasure chest and whispering, "If you figure this out, I'll tell you how everything works." And then there are the fringe tidbits. In the 1970s, some theorists speculated that black holes might be gateways to other regions of the universe, based entirely on mathematical extensions of Einstein's equations. Drawn on paper, the solutions looked like bridges connecting one spacetime to another, what we now casually call wormholes. Were they physically real? Probably not. But the equations didn't say no, and sometimes that's all a dreamer needs. As you hover here, you feel a flicker of dizziness. It's not just gravity tugging at you, it's logic itself twisting. The rules you trust on Earth, like cause precedes effect or objects can't occupy the same place at once, start to feel optional. If space can bend, maybe time can fold. Maybe those rules are local guidelines, like don't swim after eating, but out here, you're free to ignore them. You glance back at the starlight, warped into arcs and halos. It feels like being inside a funhouse mirror maze, except the maze is four-dimensional. Somewhere deep in the math, you realize relativity still works, perfectly, beautifully, until it collides head-on with quantum physics. It's like two different GPS apps telling you to turn left and right at the same intersection. The car stalls, and you're left wondering if you've discovered a glitch in reality. A joke for you. Physicists once quipped that black holes are where God divided by zero. It's not technically correct, but the sentiment fits. You're staring at the place where math stops making sense, and the rules break down in slow motion. So here you float, midway between Einstein's clean curves and quantum's jittery chaos. The black hole doesn't care which theory you choose. It simply bends space, swallows matter, and twists time. You're left trying to reconcile two incompatible rulebooks, like a chef told to bake a cake that is simultaneously vegan, keto, and entirely made of steak. And maybe that's the real thrill, standing at the crossroads of human understanding, where even the greatest equations start to look like doodles compared to the depth of the void. The pull deepens. The equations in your head don't just hum now, they throb, like a bass line rolling through space-time itself. Relativity insists you're sliding smoothly toward the horizon, but quantum theory whispers that you're about to hit something unexpected, maybe even impossible. You smile nervously, realizing that either way, the math is still writing you into its story. Closer then, always closer. You ease forward, and the pull intensifies. Not like falling down a hill, but like every atom of your body suddenly remembering it owes a debt to gravity. At first, it's subtle, a gentle stretch, as though the universe is encouraging you to practice yoga mid-air. But then the forces separate head from toe, tugging with a difference so dramatic you start to feel like a rubber band on the verge of snapping. Physicists have a name for this effect: spaghettification. Not the most dignified term, but it gets the point across. Your feet, being slightly closer to the black hole, feel a stronger gravitational pull than your head. The difference multiplies as you drift closer, until you're being stretched long and thin like cosmic taffy. In textbooks, it sounds terrifying. Here, though, the sensation is oddly slow, like the world's strangest massage chair. Imagine a spa ad. Come experience our unique full-body elongation therapy, free with every plunge into the abyss. This stretching force is caused by what scientists call tidal forces. You already know tides on Earth are pulled by the moon, raising and lowering the oceans each day. Now scale that effect up to something 4 million times the mass of our sun, and instead of waves gently lapping beaches, you get molecules unzipping. Here's a historical note to ground you. In 1783, clergyman and natural philosopher John Michell described what he called dark stars, objects so dense that not even light could escape them. He had no idea of the math of spaghettification, of course, but his intuition wasn't far off. He imagined light trapped, which is more or less what you're watching now. Still, Paul Michel didn't live long enough to coin the pasta metaphor. A quirky tidbit for your amusement. Some modern physicists speculate that, under the right conditions, spaghettification might not completely shred you. If the black hole is supermassive, like the kind at galactic centers, the tidal forces near the event horizon could be gentle enough that you'd cross without immediate shredding. It's like comparing a speed bump to a mountain cliff. The size matters. Of course, further inside, physics cashes the check your body can't pay. Historians still argue whether this gentle crossing is survivable in any meaningful sense. Could you pass through the horizon of a giant black hole without noticing? The debate continues because nobody has ever filed a Yelp review after the plunge. Yet some theorists suggest that, from your perspective, the entry might feel calm. No fireworks, no pain, just an odd stretching you barely notice until it's too late. Meanwhile, your surroundings distort. Stars above and below elongate, streaking into lines. It feels like living inside a long-exposure photograph. You wonder, half-jokingly, if your Instagram followers would appreciate the shot, currently being stretched into linguine, #nofilter. But the humour fades when you realise that not only is your body stretching, but time itself seems to thin out, drizzling like honey from a spoon. And yet, you can't help but think of how humans have always flirted with danger. People willingly strap themselves into roller coasters that simulate freefall. Climbers dangle from sheer cliffs for sport. Some even dip into hot yoga studios that are basically slow cookers for the body. By comparison, your gravitational yoga session just feels like the universe taking those hobbies to their logical extreme. The strangest part is how serene it all looks. Outside, stars don't scream, matter doesn't cry out. The black hole swallows galaxies with the same calm efficiency as someone eating potato chips one by one. No drama, just inevitability. You realise that nature's most terrifying effect dresses itself in silence. You try flexing your fingers. They respond, but sluggishly, as though each signal has to crawl across a stretched-out nerve highway. A laugh bubbles up at the absurdity. You, a human noodle drifting into the universe's strangest kitchen. If Gordon Ramsay were here, he'd probably scream that you're overcooked. And yet, there's awe beneath the absurdity. This stretching isn't just a grotesque hazard, it's proof of relativity in action. The closer you are to a source of gravity, the faster space-time bends around you. The unevenness is what pulls your parts apart. It's the same logic that makes moons orbit planets, planets orbit stars, and stars orbit the galactic core. You're just experiencing the effect directly, personally, uncomfortably. The physics tells you that once you've crossed a certain point, there's no going back. But that thought doesn't sting. Instead, it soothes, like realizing you've stepped onto a slide and all that's left is the ride down. You don't need to steer, you only need to observe. Your last glance outward catches the warped galaxy haloing the black hole. Curved arcs of light shimmer, flickering as though the universe is waving goodbye in slow motion. And maybe it is. After all, from the outside, someone watching you would never see you cross the horizon. To them, you freeze, stretched forever, a human bookmark in the margin of space-time. But from your side, the noodle keeps falling. Closer, always closer. The pasta metaphor lingers in your mind, but the sensation evolves. It's less spaghetti now and more like saltwater taffy, being pulled until it thins into threads finer than silk. A strange peace accompanies the stretch. You realize that even in distortion there's a kind of beauty, and so, elongated, fragile, but still oddly intact, you keep descending into the darkness, your body part physics demonstration, part cosmic joke. The stretching continues, but something even stranger begins to happen. Time itself no longer plays by your familiar rules. You blink and the moment feels sticky, like honey poured from a jar. Each second stretches longer than the last until your sense of now is less a beat and more a syrupy flow. To you, the fall continues smoothly. To anyone watching from outside, though, you appear frozen just above the black hole's horizon, stuck like a paused video never quite finishing the plunge. This is relativity's handiwork. Einstein showed that time runs differently depending on how strong gravity is. Near Earth, the effect is tiny. Astronauts on the International Space Station age just a smidge slower than the rest of us. But near a black hole, the time difference isn't just measurable, it's absurd. From the perspective of distant observers, you would hover forever at the edge, red-shifted into oblivion as your light fades away. To you, though, the journey continues, uninterrupted. It's like the universe is running two versions of reality simultaneously, one where you freeze and another where you fall. Historians still argue whether this is just a matter of perspective, or if both experiences somehow exist in parallel. Is time itself subjective? Or is one version more real than the other? Scholars fill papers with equations, but out here, you're the lab rat, and the experiment is still running. A famous historical example illuminates the point. In 1962, physicist Robert Oppenheimer, yes, the same man later linked to the Manhattan Project, explored how collapsing stars slow time itself. His calculations suggested that to a distant observer, a collapsing star would appear to freeze as it approached its event horizon. The object never seems to vanish, it just lingers, forever dimming. The poetic image earned the name Frozen Star. But from the star's perspective, the collapse finishes. Both stories are true, depending on where you stand. A quirky tidbit: some sci-fi fans like to imagine camping near a black hole to binge-watch the universe. In theory, you could sit close enough the time for you slows dramatically, while the cosmos outside ages billions of years. It's the ultimate spoiler seat. You could in one afternoon watch stars form, galaxies collide, and civilizations rise and fall. The catch, of course, is surviving the tides and radiation long enough to enjoy the show. Bring snacks if the physics allows. Back in your perspective, the airless void presses silently, but time continues to drip. Your body is still stretching, but now the strangeness of time eclipses even the spaghettification. You glance back at the stars outside. They're racing, burning brighter, then fading, as though centuries are passing in their glow while your own heartbeat keeps its rhythm. It feels like sitting in a train station while the trains rush by at impossible speeds and you alone remain seated on the bench, unhurried. Here's where the joke sneaks in. If you ever wanted a magic trick to skip waiting rooms, you've found it. The dentist's chair, gone in an instant from your view. Taxes, already filed 1,000 years ago. You, meanwhile, drift calmly in your stretched-out body, the universe doing all the rushing for you. You notice, too, that sound doesn't matter here. Outside, if someone shouted your name, the cry would never reach you. Light itself struggles, its wavelength stretched longer and longer, until it disappears into invisible radio waves. It's called redshift, but to you, it feels like the cosmos whispering goodbye in slower and slower tones, until the whisper dissolves into silence. The philosophical question scratches at you. What does it mean to freeze in someone else's eyes while continuing in your own? Which story is the truth? Maybe truth itself is relative, like the experience of time. Historians of science point out that debates about the nature of time go back to Augustine, who famously said he understood time until someone asked him to explain it. Centuries later, Einstein turned the same puzzle into equations, and here you are, living the paradox firsthand. You drift deeper. Your heartbeat feels steady. Those stretched seconds make it echo oddly in your chest. If an outside observer could still glimpse you, they'd swear you were stuck at the rim forever. From their point of view, you've become a ghost frozen in space-time, an eternal warning sign on the black hole's edge. But from your perspective, the journey has barely begun. Both realities insist on their truth, and you inhabit them both at once. It's dizzying to think about, but oddly calming. Time's syrupy slowdown doesn't bring panic, it brings quiet. Imagine being given an endless pause button for your own life, where each instant lasts long enough to notice every detail. The curve of a distant star, the shimmer of bent light, the gentle stretch of your own body. No deadlines, no clocks, no alarms, just syrupy time. And so you keep falling, slowly and quickly, frozen and moving, alive in two conflicting versions of the same story. The honey drips on, sticky, golden, impossible to wipe away. The syrupy flow of time continues, but as you inch nearer to the invisible boundary, another possibility intrudes on your thoughts. What if the horizon isn't smooth at all? For decades, physicists pictured it as harmless, like slipping through a doorway into deeper darkness. But then came the firewall paradox, a theoretical grenade lobbed into the quiet corridors of black hole physics. According to some interpretations of quantum mechanics, instead of a gentle crossing, you'd slam headfirst into a blazing wall of pure energy. Picture this. You've braced yourself for a silent fall, maybe some stretching, maybe some strange views of distorted stars. Instead, the moment you brush the event horizon, reality itself bursts into flames, vaporizing you instantly. Not exactly the calm cosmic spa you were promised. Scientists call this the firewall, though cosmic blowtorch might have been more accurate. The paradox arises from the clash of two sacred principles. On one hand, relativity says the horizon should be smooth and uneventful, no drama as you drift past. On the other, quantum mechanics insist that information can't be destroyed. Combine those with the black hole's appetite, and you get contradictions that make even the most confident physicist rub their temples. The firewall proposal is one way to resolve the conflict. Destroy the falling observer at the horizon so information doesn't vanish. Problem solved, except, well, not really. A little historical grounding. In 2012, a group of theorists, Almhiri, Marolf, Polchinski and Sully, collectively nicknamed AMPS, formalized this argument, sparking a frenzy in the physics world. Suddenly everyone was debating whether black holes were peaceful gateways or fiery death traps. Entire conferences were hijacked by the question. You can almost imagine the panel discussions. Good evening, ladies and gentlemen. Today we ask, will you fry instantly, or will you glide gracefully into the void? Not exactly the bedtime story you'd expect from Einstein's legacy. A quirky tidbit here. Some physicists jokingly compare the firewall idea to a cosmic bouncer. You try to sneak into the club of the black hole interior, and the universe says, nope, not on the list, before tossing you out in a blaze. It's a rare case of high-level theoretical physics being indistinguishable from nightclub gossip. Historians still argue whether firewalls are truly necessary, or if the paradox points to a deeper, unknown theory that reconciles relativity and quantum mechanics without incinerating curious travelers. Some dismiss the firewall entirely, calling it an inelegant patch. Others insist it might be real, a dramatic hint that our understanding of space-time has blind spots. The debate is ongoing, heated and deliciously unresolved. As you approach the horizon, you can't help but wonder, will it feel like slipping into a warm bath or sprinting headfirst into a cosmic bonfire? There's no way to know until you cross. The thought nags at you. The event horizon, once imagined as calm, now flickers in your mind's eye as a potential curtain of fire. Still, from your perspective, nothing unusual glows ahead. No flames, no shimmering barrier, no sci-fi force field. Just the same silent darkness, beckoning. If there is a firewall, it hides itself well, waiting until the last moment to spring. That's the cruel elegance of the paradox. You'd never know until you were part of the experiment, and then you'd be too vaporized to file a report. You can almost hear the universe laughing at you softly, with that smug voice it reserves for species who think they've figured things out. Oh, you thought you could just walk in? Cute. But here's a joke for your nerves. If you do burst into flames at the horizon, at least you won't need to pack marshmallows. The black hole supplies all the roasting power you'll ever need. The thought lingers. Whether or not the firewall exists, the paradox itself is valuable. It's a signpost pointing toward new physics. The clash between relativity and quantum theory is less a roadblock and more a neon arrow flashing dig here. Maybe the true answer will one day bridge the divide, a grand theory stitching together gravity and quanta in a way that smooths over firewalls. Until then, though, you hover between two possibilities, quiet crossing or sudden combustion. You take a deep breath, not that there's air here, and steady yourself. If the firewall is real, you'll never know what lies beyond. If it isn't, you'll keep falling into deeper mysteries. Either way, the horizon is no longer just a line, it's a question mark scrawled across space-time. The pull grows stronger, your stretched body drifts toward the threshold. No flames greet you yet, but the possibility flickers in your mind like static on an old TV screen. Whatever waits, smooth or searing, you're about to find out. The horizon swells larger now, no flames in sight, just a smooth, shadowed edge where the laws of physics blur. Yet in the quiet hum of your stretched-out fall, another idea bubbles up. What if this isn't the end at all? What if black holes don't just swallow? They connect. The whispers of wormholes flicker through your thoughts like rumours overheard in a dark cafe. Mathematically, wormholes, technically Einstein-Rosen bridges, fall straight out of general relativity. In 1935, Einstein himself, working with physicist Nathan Rosen, explored solutions to his field equations that linked two distant regions of space-time with a tunnel. Imagine folding the universe like a sheet of paper and poking a pencil through. Suddenly, points light years apart now touch. That's a wormhole in a nutshell. In their equations, the mouths of these tunnels look suspiciously like black holes. The thought tickles you. Maybe the horizon ahead isn't a wall or a fiery bouncer, but a doorway. Step through, and instead of obliteration, you find yourself spat out somewhere else, across the galaxy, across the universe, or maybe even across the boundary of reality itself. A shortcut the cosmos forgot to hide properly. A quirky tidbit here. In the 1980s, physicist Kip Thorne, later famous for consulting on Interstellar, played with the possibility of traversable wormholes. He even fielded questions from none other than Carl Sagan, who wanted a scientifically plausible way for characters in his novel Contact to travel across vast cosmic distances. Thorne's calculations, though, revealed a frustrating caveat. Wormholes could only stay open if they were stabilized by exotic matter, stuff with negative energy. Normal matter just collapses the tunnel like wet cardboard. Exotic matter, meanwhile, has never been spotted outside of theory. Historians still argue whether wormholes are physically real or just pretty mathematical mirages. Are they genuine features of space-time, waiting for us to stumble into one? Or are they artifacts of equations stretched past their breaking point? Some scholars even wonder if black holes might hide wormholes in their cores, but with no way to peek inside, the question remains suspended like a rumour passed down through generations of theorists. As you float closer, the warped starlight around you seems to tease the idea. Galaxies stretched into arcs look like doorframes. Rings of light flicker like invitations. You imagine stepping through one and suddenly standing beneath alien suns, their skies painted in colours human eyes have never named. Maybe you'd stumble onto a world with seas of liquid diamond, or a civilization that figured out laundry long before faster-than-light travel. Of course, the more you think about it, the more absurd it sounds. Wormholes, if they exist, are probably as unstable as soap bubbles. Step inside, and the tunnel pinches shut, cutting you off mid-journey. You might emerge at the other end, or you might end up smeared across space-time like butter on too much bread. Not the most glamorous way to travel. Still, you can't help but let the daydream linger. Humans are wanderers by nature. We climbed down from trees, crossed continents, and flung ourselves into orbit. The idea of a cosmic shortcut scratches that same itch. A wormhole isn't just physics, it's an invitation, a whisper from the universe saying, what if there's more? Here's a joke to lighten the mood. If wormholes ever become real tourist attractions, you can bet the brochures will brag, "Skip traffic, save light years. Just don't forget your exotic matter carry-on." The silence presses in again, heavier now, the black hole's pull undeniable. You realise that, wormhole or not, you're going in. Maybe it's nothing more than a hungry singularity, grinding space-time into pulp, or maybe, just maybe, you're about to walk through a cosmic tunnel dug by Einstein's own math. The horizon waits, smooth as glass, silent as breath held. No signs, no labels, no arrows pointing this way to portal. Just a void that might be a passage. And so, you fall. Curiosity outpacing fear, the whispers of wormholes tugging at your thoughts like strings leading you deeper. The whispers of wormholes still echo in your mind, but the thought takes a new twist. If black holes can, in theory, open tunnels, then what about the opposite? Instead of devouring everything, imagine an object that only spits things out. Welcome to the bizarre speculation of white holes. A white hole is the cosmic flip side of a black hole, a solution to Einstein's equations that runs time in reverse. Where black holes suck in matter and light, white holes eject them, refusing entry entirely. You picture it like a stubborn toddler of the universe. "No, you can't come in, but here, have all this junk I don't want." The equation suggests that whatever falls into a black hole might, under the right circumstances, come blasting out of a white hole elsewhere, possibly in another region of space-time. Historically, the idea cropped up in the 1960s as physicists explored the full mathematical extensions of the Schwarzschild solution. White holes looked neat on paper, symmetrical and logical, but whether they exist in reality, that's another story. Historians still argue whether white holes are genuine predictions or just quirks of math that nature politely ignores. A quirky tidbit for your amusement. Some theorists once suggested that the Big Bang itself could have been a kind of white hole, an explosive event spewing matter and energy into existence without a past. In that sense, you might already be living inside the ultimate white hole, the byproduct of some long-forgotten cosmic collapse. That's the kind of bedtime story that makes you glance nervously at the ceiling before sleep. As you imagine white holes, the contrast is delicious. Black holes swallow, white holes spit. One devours stars like snacks, the other belches them back into space. You chuckle, thinking the cosmos basically invented recycling long before humans figured out plastic bins. The concept stirs another thought. What if the black hole you're falling into is only half the story? What if, somewhere far away, or far elsewhere, there's a white hole preparing to exhale everything this one swallows? You, your elongated atoms, the starlight you saw bent, the entire history of matter collapsing inward. Maybe it all has an exit. It's comforting in a strange way, like realizing that even if the universe eats you, it might eventually burp you out again. But practical problems loom. For one thing, no one's ever observed a white hole. They'd be ridiculously bright, ejecting radiation and matter non-stop, and astronomers haven't spotted anything behaving like that. The closest cousins we know are quasars, blazing galactic cores powered by black holes feasting on matter. Some fringe thinkers once tried linking quasars to white holes, but the evidence doesn't fit. So far, white holes remain purely hypothetical, mathematical phantoms haunting the edges of relativity. And yet, as you drift, the image won't leave you. You imagine bursting out of another sky, perhaps in some distant galaxy where the stars burn green instead of gold. You picture alien astronomers watching in shock as a noodle-shaped traveller sprays out of their local white hole like cosmic confetti. You'd never survive the trip, but the thought makes you grin. Here's a light joke to keep your spirits up. If black holes and white holes are opposites, then maybe the universe is just one giant cosmic washing machine. Matter goes in dark, tumbles around, and comes out fresh and bright on the other side, hopefully with less lint. The deeper you fall, the more the notion lingers. Maybe destruction isn't the endgame. Maybe collapse leads to release. Maybe black holes aren't prisons, but bridges with exits you can't yet see. Whether or not white holes are real, the thought of them softens the void ahead, turning it into less of a death sentence and more of a strange passageway. Still, the horizon grows, silent, smooth, unblinking. No white light pierces the dark. For now, all you have is theory and the quiet hope that somewhere, sometime, the universe does spit things back. The theories swirl in your head. Wormholes, white holes, firewalls. but the horizon keeps tugging you closer, and your thoughts fix on a specific destination. Not just any black hole, but the black hole, the monster lurking at the very heart of our galaxy. Astronomers call it Sagittarius A star, though the name sounds more like a star rating for a mediocre restaurant than a 4 million solar mass beast. You picture it now, tucked inside the crowded centre of the Milky Way, hidden behind dust clouds and glowing gas. For decades, it was a mystery. Astronomers suspected something enormous lurked there because stars near the galactic core were whipping around at breakneck speeds like bees orbiting an invisible hive. In the 1990s, careful observations revealed the truth. These stars were dancing under the gravity of a compact, unseen colossus. The only explanation: a supermassive black hole quietly anchoring the galaxy. A historical note for you. Andrea Ghez and Reinhard Genzel shared the 2020 Nobel Prize in Physics for mapping the orbits of those stars. Their painstaking work confirmed Sagittarius A star's mass and gave humanity its most compelling evidence yet that supermassive black holes really exist. Imagine the patience, watching tiny points of light for decades just to confirm that the universe hides monsters in plain sight. A quirky tidbit. In May 2022, astronomers finally captured the first radio image of Sagittarius A star. Unlike the dramatic silhouette of M87's black hole, the first one ever imaged in 2019, our galactic centre looks fuzzier, like a cosmic donut made by someone slightly tipsy. The reason? Sagittarius. A gobbles food more slowly and chaotically, so its light flickers like a candle in wind. Still, there it is. Proof that the centre of our home galaxy is a hole you could fit millions of suns inside, spinning in darkness. Historians still argue whether supermassive black holes like Sagittarius A star form from the collapse of giant gas clouds, the merging of smaller black holes, or some primordial process tied to the early universe. The debate simmers, fueled by data but unsolved. No one yet knows how these titans were born so quickly after the Big Bang. It's a cosmic origin story waiting for its final chapter. As you drift, you imagine navigating the busy stellar neighbourhoods near the galactic centre. Stars swing dangerously close to one another, comets get slingshotted like cosmic pinballs, and gas clouds spiral in like moths to a flame. The entire region hums with chaotic energy, and in the middle sits Sagittarius A star, calm as a spider in its web. You smirk at the thought. People worry about traffic jams on highways, but here, whole stars weave through an invisible rush hour, racing at thousands of kilometers per second, and yet, instead of honking horns, the soundtrack is silence punctuated by gravitational waves. Here's your light joke. If humanity ever markets space tourism, you can bet Sagittarius A star will be on the brochure. Visit the heart of the Milky Way, complimentary spaghettification included. Of course, the return trip may be complicated. You lean into the idea that this black hole is special. Not just because it's nearby in cosmic terms, but because it's ours, the Milky Way's heartbeat. Every star you've ever seen in the night sky, every planet, every atom of your body, all of it quietly orbits this central abyss. It's strange comfort. The monster in the middle is also the glue holding your cosmic family together. Closer you fall, and though your own horizon looms large, your thoughts tether to Sagittarius A star's reality. It isn't just theory or rumour, it's a fact carved into the stars themselves. And the knowledge makes the darkness ahead less alien. After all, you've been orbiting one black hole your whole life. Your gaze drifts from the galactic centre back to the origin of the thing itself, the moment a star dies too spectacularly to fade quietly. Black holes don't appear out of nowhere. They are born, like everything else in the universe, from a process with a messy backstory. You imagine the life of a massive star, tens of millions of years burning furiously, fusing hydrogen into helium into heavier elements, climbing the periodic table rung by rung until it runs out of fuel. Without fusion to hold it up, gravity wins. The star collapses inward, its outer layers slamming down in a final act of cosmic theatre, a supernova. The explosion rivals an entire galaxy's light for a few brief weeks. Civilizations, if they exist nearby, might have rewritten myths around that blaze. And when the fireworks fade, what remains is a core crushed into something unimaginably dense. If the remnant is small enough, you get a neutron star, city-sized, but with the mass of a sun. If it's bigger still, Gravity doesn't stop at neutrons. It keeps crushing until even light has no way out. And just like that, a black hole is born. A historical note: the first black hole candidate ever identified was Cygnus X1, discovered in the 1960s. Astronomers noticed powerful X-rays streaming from a region in the constellation Cygnus, and soon realized it came from a star orbiting something invisible but massive. It was our first strong evidence that stellar corpses could collapse into the monsters theory had long predicted. Stephen Hawking famously bet against it being a true black hole, then later conceded, a rare moment of public humility from a physicist who spent decades redefining the field. A quirky tidbit: some ancient cultures may have unwittingly seen supernovae that created black holes. Chinese astronomers recorded a guest star in 1054 CE, so bright it was visible during the day for weeks. That explosion left behind the Crab Nebula and a pulsar at its centre. If the star had been a bit more massive, it might have collapsed into a black hole instead. Imagine peasants in medieval China pointing to the blazing sky, not knowing they were witnessing the universe giving birth to one of its strangest objects. Historians still argue whether all black holes we see today formed from stars, or if some date back to the dawn of time. So-called primordial black holes, born just after the Big Bang, could range in size from mountains to atoms. Some scientists even speculate they might make up dark matter, the mysterious stuff outweighing normal matter in the universe. But evidence remains thin, the debate unresolved. You float deeper, and the thought of stellar death feels oddly intimate. Stars are both nurseries and graveyards. Every atom in your body heavier than helium was forged in a star's furnace or a supernova's blast. In a way, black holes are like cosmic compost bins, recycling the end of one star into something that might shape the destiny of galaxies. The imagery sharpens. You picture the violent implosion, the shockwave ripping outward, the star's core buckling under its own weight. Then the silence that follows, broken only by the gravitational field left behind, invisible yet irresistible. There's beauty in that silence too. A star burns out, but in its death throes, it creates something so strange it bends the rules of reality. A joke slips through. People talk about leaving a legacy after death: children, books, buildings. But compared to collapsing into a black hole, everything else feels like amateur hour. I want my legacy to be a singularity, you imagine a star bragging, smug to its end. As you keep falling, you realize black holes aren't so much objects as processes, living chapters in the lives of stars. They're reminders that endings can be beginnings, that collapse can lead to gateways, and that even destruction has a role in the larger design. And with that realization, the pull strengthens again, as though the black hole itself is saying, enough backstory. Time to meet your own ending, or your own beginning. You drift in silence, the memory of stellar death still flickering in your mind, when another thought presses forward. What if black holes themselves don't last forever? They seem immortal, eternal vacuums swallowing all that comes too close. But in the 1970s, Stephen Hawking turned that myth on its head. He showed that black holes, paradoxically, can glow. Not glow in the ordinary sense, no fiery light or shining surface, but through the jittery rules of quantum mechanics. Space, even the emptiest vacuum, isn't truly empty. It teems with virtual particles, tiny pairs that pop into existence and annihilate each other almost instantly. Normally, this dance leaves no trace. But near a black hole's event horizon, things get messy. If one particle falls in while the other escapes, the survivor drifts away as real radiation. The effect is faint but relentless. Over unimaginable spans of time, the black hole bleeds energy into the cosmos. This is Hawking radiation. It's an elegant twist. The very thing thought to swallow everything turns out to leak. Big black holes evaporate slowly, like ice cubes in a desert, their lifetimes stretching far beyond the current age of the universe. Smaller ones, though, might fizzle more quickly, eventually ending with a spectacular burst of energy. A cosmic fireworks finale. A historical fact here: Hawking's 1974 calculation shocked the physics community. Even his colleagues assumed black holes were perfect prisons. When he suggested they decay, it wasn't just a tweak, it was a revolution. It linked gravity, quantum mechanics, and thermodynamics in one surprising equation, hinting that black holes have entropy and temperature. In other words, They're not just dark pits, but thermodynamic objects with their own heat signature. A quirky tidbit: Hawking once bet against the existence of Hawking radiation, partly to cover himself in case he'd made an error. He joked that hedging his bets meant he'd either win the argument or win the satisfaction of being right. Classic physicist humour, simultaneously brilliant and self-deprecating. Historians still argue whether Hawking radiation has ever truly been observed. In practice, it's far too weak to detect from black holes in space. The radiation is dwarfed by other cosmic noise. But in 2010, physicists created analog black holes in the lab, using fluids or light trapped in special materials to mimic event horizons. Some of these experiments hinted at Hawking-like radiation, though skeptics point out that laboratory imitations may never perfectly capture the real thing. The debate continues, lively as ever. As you fall closer, the idea hums through your mind. Nothing lasts forever, not even black holes. The giants anchoring galaxies will one day fade into whispers of radiation, evaporating across trillions upon trillions of years. The cosmos itself is a patient accountant, balancing its books slowly but surely. You glance outward, imagining the far, far future when Sagittarius A star itself is gone. Stars will burn out, galaxies will drift apart, and even the titans of gravity will vanish into sparks of radiation. The universe may end not with bangs, but with countless faint hisses. It's oddly comforting. Even these colossal monsters, which seem so final and merciless, are temporary. They too are folded into the cycle of creation and decay. The abyss has an expiration date stamped in math, invisible but inevitable. Here's a joke to lighten the melancholy. If black holes eventually evaporate, then technically the universe is on a very slow diet. Cosmic Weight Watchers. Results guaranteed in 10 to the 100th power years or your money back. The thought sticks with you as you keep falling. The black hole pulling you in is ancient but not immortal. You're entering a chapter of its story, not its epilogue. Somewhere, eons from now, the radiation bleeding from its horizon will carry away even the energy of your plunge. Nothing is truly lost. And so you continue, sliding closer to the threshold, knowing that even the darkness swallowing you is itself on borrowed time. The thought of Hawking radiation still lingers, black holes fading like embers over eons, but another question rises up, sharper, stranger. What exactly happens at the very centre? That's where the equations point toward the dreaded singularity, a place where density soars to infinity and space-time curves so sharply the math itself screams, does not compute. Here's the catch. Physicists hate infinities. An infinity in an equation usually means you've pushed your theory past its breaking point. So, do singularities actually exist, or are they just signs that our models are incomplete? That question birthed one of the strangest debates in modern physics, cosmic censorship. The idea was proposed by Roger Penrose in 1969, and it's almost comically polite in its phrasing. He suggested nature censors singularities, hiding them behind event horizons so no one in the outside universe can ever actually see one. In other words, yes, singularities may exist, but you'll never get a glimpse. They're covered up by space-time's own modesty curtains. A historical fact here: Penrose's work on singularities, and later his contributions with Stephen Hawking, was so groundbreaking that he received a Nobel Prize in 2020. He showed mathematically that once a massive star collapses, singularities aren't just possible, they're inevitable. Gravity doesn't stop halfway, it dives all the way down. A quirky tidbit: the phrase naked singularity is the technical term for what happens if the censorship fails, if the singularity is laid bare without an event horizon to cloak it. Some theorists have actually explored this possibility, with all the awkwardness the name implies. A naked singularity would be physics streaking across the cosmos, violating every polite boundary of cause and effect. The universe apparently has a sense of humour when naming its paradoxes. Historians still argue whether cosmic censorship is true. For decades, most physicists assumed it was, because the alternative is chaos. Naked singularities would allow unpredictable things to happen, breaking determinism itself. The comforting rule that the future follows logically from the past would collapse, but numerical simulations of collapsing stars occasionally hint that censorship might not always hold. The jury remains out, and the arguments get fiery. You imagine it now, falling all the way through, bypassing horizons, and staring at a singularity unclothed. What would it look like? No one knows. Some say it would defy description entirely. Others think quantum gravity, the elusive theory marrying Einstein's spacetime with quantum mechanics, would smooth it into something finite and well-behaved. For now, the singularity remains a mathematical mirage, more question than answer. The imagery is almost comical. The universe builds the ultimate stage trick, a collapsing star turning into a region where even time and space lose their roles. And then it slams the curtain shut, as if to say, "Sorry, show's over. No refunds." You chuckle softly at the thought. Humans cover their embarrassments with fig leaves, while the cosmos uses horizons. Same instinct, different scale. Still, the seriousness presses back in. If singularities are real, then deep inside this black hole lies the most extreme condition imaginable. Not just matter crushed beyond atoms, beyond neutrons, but all the way down to the unnameable. If cosmic censorship holds, you'll never see it. If it doesn't, well, you won't live to tell the tale anyway. Either way, the mystery is absolute. And yet, part of you thrills at the thought. Naked singularities, censorship, infinities, all of it means we don't yet have the final word. Physics is still a work in progress, scribbles in the margin of the universe's diary. You're just falling through one of its juiciest footnotes. The horizon looms larger, the pull sharper. Somewhere inside, singularities, clothed or not, wait. For now, though, you hover in uncertainty, balanced between Penrose's tidy censorship and the possibility that the cosmos occasionally forgets to pull the curtain shut. The thought of a hidden singularity fades into the background, replaced by another possibility that's even stranger. What if the black hole doesn't crush you into nothing, but instead opens into a tunnel, a wormhole that could actually be held open? That's the dream physicists toy with, but there's a catch. You'd need a ticket made not of paper or metal, but of exotic matter. Exotic matter isn't science fiction's slime glowing in neon green, though that mental image is fun. It's a hypothetical form of material with negative energy density, the opposite of everything you've ever known. Whereas ordinary matter curves space-time inward, exotic matter would push it outward. Think of it as anti-gravity fuel, capable of propping open a wormhole that would otherwise collapse in on itself. Without it, any tunnel through space-time pinches shut before you could even poke your head inside. A historical anchor. In 1988, physicists Michael Morris and Kip Thorne published a famous paper exploring traversable wormholes. They concluded it was theoretically possible, so long as you could gather and control enough exotic matter. Thorne even partly pursued this line of thinking after Carl Sagan asked him for a plausible interstellar travel method while writing Contact. Science inspiring fiction. Fiction inspiring science. The loop is neat. A quirky tidbit. In certain experiments, physicists have coaxed tiny patches of negative energy using the Casimir effect, where two metal plates placed extremely close together trap quantum fields in a way that produces a measurable negative pressure. It's microscopic and nowhere near the scale needed for wormholes, but still, a laboratory glimpse of the stuff that could, in principle, stabilize a cosmic tunnel. Historians still argue whether exotic matter could ever exist in large amounts. Some say it's impossible, just a loophole in the equations. Others argue it might lurk in phenomena we haven't yet recognized. The debate is lively because the stakes are delicious. If exotic matter is real, wormholes move from pure fantasy to extremely unlikely, but maybe. You imagine now drifting closer, clutching a ticket of exotic matter like a golden boarding pass. The horizon ahead isn't a doom wall, but a doorway held ajar by anti-gravity scaffolding. You step through, and instead of death, you emerge somewhere else. Maybe another galaxy, maybe another time. The physics doesn't forbid it outright. It just demands a fuel no one knows how to make in bulk. You laugh softly. Humans struggle to power electric cars consistently, and here we are, daydreaming about fueling intergalactic tunnels with negative energy. Ambition has never been our problem. Supply chains always are. The silence of your fall presses in, and yet the thought gives you hope. Exotic matter is the cosmic what-if tucked in relativity's back pocket. Even if no one ever finds it, the fact that equations allow it suggests the universe might not be as locked down as it seems. A joke sneaks in. If exotic matter were ever sold, you can bet it would be outrageously overpriced. One vial of negative energy, $9.99 trillion, no refunds, and don't ask why the bottle looks empty. The horizon glimmers faintly, warped light bending around it like strands of silk. In that distortion, you picture a wormhole mouth shimmering, propped open by invisible exotic braces. Maybe it's wishful thinking. Maybe it's just the void playing with your imagination. But the possibility is there, stitched into the equations, teasing you with a door you can't quite see. And so you fall, wondering whether anyone will ever hold that ticket. Negative energy in hand, stepping confidently through a tunnel the cosmos might just allow. The thought of exotic tickets lingers as you drift deeper, but another possibility takes over now. Wilder, stranger, harder to shake. What if black holes don't just connect distant points of our universe? What if they open into other universes altogether? The idea isn't new. Some physicists, following the math to its wild conclusions, have speculated that every black hole could be the seed of a new cosmos. Picture it. When matter collapses past the horizon, it doesn't just vanish. It re-emerges as the Big Bang of another universe, an entirely fresh reality budding off like a cosmic branch. From the outside, all you see is darkness. From the inside, an entire new space-time may be blossoming. A historical note here. In the 1960s, theorists like Igor Novikov and others explored white hole solutions that naturally suggested new universes could emerge beyond the horizon. Later, in the 1980s, Lee Smolin took the idea further, proposing cosmological natural selection, a theory where universes reproduce via black holes, each with slightly different laws of physics. The picture is almost biological. Universes having children, some thriving, some fading, all competing in an eternal Darwinian game. A quirky tidbit. Some fringe thinkers even suggest that the fine-tuned constants in our universe, the delicate balance that allows atoms, stars, and life, exist because they were inherited. If true, then your entire existence might be thanks to some ancient black hole, parent universe tweaking its own constants. You are, in a sense, the descendant of a star that collapsed billions of years ago in another cosmos. Family reunions would be complicated. Historians still argue whether these multiverse speculations are physics or philosophy dressed in math. After all, how could you ever test them? You can't exactly poke your head into another universe and report back. Some argue the theories are unscientific because they're unfalsifiable. Others insist they may become testable indirectly, through imprints in cosmic background radiation or subtle signatures in black hole behaviour. For now, the debate simmers, tantalising and unresolved. As you fall, the imagery consumes you. What if your plunge doesn't end in destruction but in creation? What if your stretched out body, your atoms, your very information becomes the scaffolding of a newborn universe? It's a strangely hopeful thought. Not death, but rebirth on the grandest possible scale. You imagine standing inside that new cosmos as it expands, stars igniting, galaxies swirling, perhaps even new forms of life rising. From their point of view, the Big Bang is a beginning. From your point of view, it's a continuation. You laugh at the irony. You might end up as the reluctant midwife to another universe. Not a bad resume entry, really. Here's a joke to lighten the metaphysics. If universes really do reproduce through black holes, then technically you're falling into the ultimate maternity ward. Congratulations, it's a bouncing baby cosmos. Please ignore the spaghettified remains of the delivery team. The more you think about it, the more the paradox comforts you. Falling into a black hole no longer feels like pure annihilation. Maybe it's a passage, a handoff. The universe that raised you simply nudges you into the cradle of another. The horizon glimmers close, silent and smooth. Whether it hides destruction, firewalls, wormholes, or entire universes being born, you cannot yet know. But the thought that your fall might feed creation, not just death, soothes you as the pull deepens. The idea of birthing new universes still shimmers in your mind, but the silence doesn't last. A low, invisible thrum begins to ripple through space-time itself, vibrating like the faintest bass line. It's not sound, you'd need air for that. It's the fabric of the cosmos quivering. You're brushing against the aftermath of one of nature's loudest events, black holes colliding. These collisions are cataclysmic. Two black holes spiral around each other for millions of years, their orbits shrinking as they radiate energy. When they finally smash together, The impact shakes space-time like a drum. The ripples spread outward at the speed of light, gravitational waves, warping distances by less than the width of a proton, yet across galaxies. A historical note: Albert Einstein predicted gravitational waves in 1916, but he doubted they'd ever be detected. They seemed too faint, too subtle. Yet in 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, recorded the telltale chirp of two black holes merging more than 1 billion light-years away. That tiny signal confirmed a century-old prediction and earned the 2017 Nobel Prize in Physics. Humanity had, at last, learned to listen to the universe's hidden music. A quirky tidbit: the collision detected by LIGO released more energy in a fraction of a second than all the stars in the observable universe combined, yet we felt it only as a microscopic ripple. Imagine a cosmic orchestra blasting every instrument at once, but you only hear the faintest hum through a wall. It's humbling and a little comical. Historians still argue whether gravitational wave astronomy will reveal surprises beyond mergers. Could we one day detect signals from primordial black holes, or even from exotic objects like cosmic strings? The field is barely a decade old, and the debates are lively, the possibilities dizzying. As you drift, you imagine those ripples washing past you. They don't push or shove, they stretch and squeeze, altering distances so minutely you can't feel it. Yet they carry stories of collisions that happened before humans walked upright. Somewhere out there, two black holes dance themselves to death, and you're catching the echo. The picture sharpens in your mind. Two dark spheres circling, spiraling faster and faster until they smash together. The collision is silent, invisible, but space-time itself wobbles outward, broadcasting the news. Attention, universe. Another merger has occurred. Please update your cosmic records. You smirk at the thought. Humanity celebrates fireworks on New Year's Eve, yet the galaxy throws collisions that dwarf all fireworks forever. And still, our instruments strain to hear even a whisper of them. The contrast feels almost unfair. Nature's biggest concerts are inaudible to us, unless we build detectors the size of continents. A joke bubbles up. If aliens ever run a radio station on gravitational waves, humans will have the worst reception in the neighborhood. Sorry, can't tune in your channel. Our detectors only pick up faint chirps from 1 billion years ago. Still, the awe lingers. Gravitational waves prove that the universe isn't static, isn't silent. It quivers, it hums, it vibrates with the memory of unimaginable collisions. Black holes aren't just destroyers, they're drummers, keeping time on the largest stage imaginable. As you fall, you realize the thrum isn't only outside, it's inside you too. Every atom, every stretched fiber trembling faintly in rhythm with the universe's beat. The cosmos doesn't just surround you, it plays through you. And with that vibration still humming in your bones, you drift nearer the horizon, wondering what other music the black hole might be hiding. The ripples fade, but their echo lingers in your stretched body. Collisions, waves, rhythms, they all circle back to one haunting puzzle. What happens to the information of everything a black hole swallows? Does it vanish, erased forever? Or is it hidden, scrambled into space-time like ink swirling in water? This is the infamous black hole information paradox, and it's one of the juiciest unsolved riddles in all of physics. Information here doesn't mean gossip or Wi-Fi passwords. It's the physical details about the state of particles, their positions, energies, spins. Quantum mechanics insist that information is never lost. Burn a book and the words are gone, but in principle the ashes, smoke and heat still encode the data of what was written. A black hole, though, it looks like it shreds information completely, swallowing matter without leaving any trace. That breaks the rules of quantum theory. A historical anchor. In the 1970s, Stephen Hawking doubled down on this puzzle. His calculation of Hawking radiation suggested that black holes radiate energy randomly, like static noise. If true, the radiation carries no record of what fell in. That would mean the information really is destroyed, a direct violation of quantum mechanics. Hawking famously bet other physicists in 1997 that information vanishes, only to later concede he was wrong. A rare scientific oops, though in fairness, it took decades of debate for anyone to even lean toward the opposite conclusion. A quirky tidbit. In 2004, Hawking presented his reversal at a conference in Dublin. To settle the bet, he handed over a baseball encyclopedia to John Preskill, one of his challengers, joking that it represented information successfully retrieved from a black hole. Even geniuses have to pay up. Historians still argue about the resolution. Some theories suggest information gets smeared across the event horizon in a hologram, never actually lost. This idea, called the holographic principle, implies that our entire universe might itself be a projection from a distant cosmic surface. Others argue information seeps out through subtle patterns in Hawking radiation, encoded too faintly for us to notice. Still others cling to more radical options: firewalls, wormhole connections, or new physics entirely. As you drift, you imagine your own story being written into the paradox. The atoms of your body, the memories, the thoughts, all of it slipping past the horizon. Will your information dissolve into nothing? Or will it be preserved, flattened like a sticker on the event horizon surface, waiting for some future physicist to decode? You smirk at the absurdity. You might end up as part of the universe's largest filing cabinet, your life compressed into a two-dimensional hologram. Not the afterlife you were promised, but at least you'd be organized. The paradox gnaws at you, though. If information can be lost, quantum mechanics cracks. If it can't, then our understanding of space-time needs rewriting. Either way, the black hole is the courtroom where the laws of physics put each other on trial. A joke helps lighten the heaviness. If black holes really do erase information, maybe they're just doing what your brain does with embarrassing memories. Nope, that never happened. Deleted permanently. Still, the seriousness returns. This isn't just about physics trivia, it's about the foundations of reality, whether the universe is deterministic or not, whether cause truly links to effect. The information paradox remains unsolved, unresolved, unyielding, and you, noodle-shaped traveller, are slipping right into the heart of it. The horizon looms. If your information survives, it may one day radiate outward, scrambled but present. If it doesn't, then your story ends here, wiped from the cosmic ledger. Either way, you're about to contribute to the biggest unsolved mystery of them all. The paradox hums at the back of your mind, but now a new curiosity takes hold. What if you could explore all of this without actually risking noodleification? Lucky for you, scientists have been building black holes you can visit safely, digital ones. You won't feel the pull of gravity or the syrupy flow of time, but simulations give you a front-row seat to the abyss. Supercomputers have become cosmic theatres. Feed Einstein's equations into their processors, let them chew through billions of calculations, and they spit out visualizations of what a plunge into a black hole might look like. The result? Starlight curving into glowing rings, galaxies smeared into surreal spirals, and horizons looming as smooth, perfect shadows. Watching these is like binging a nature documentary, except the narrator is space-time itself. A historical anchor, one of the most famous simulations, came from physicist Jean-Pierre Luminet in 1979. Using pencil, paper, and early computers, he calculated how light would distort around a black hole and hand-drew the results. His glowing disk image looks eerily like the photograph of M87's black hole captured 40 years later. Sometimes, imagination and math beat even the biggest telescopes to the punch. A quirky tidbit: modern VR programs now let you fall into simulated black holes. Astronomers and artists collaborate to create experiences where you can strap on a headset and drift into warped space-time without leaving your couch. Sure, you still look silly waving your arms in the living room, but it beats actual spaghettification. Historians still argue whether these simulations reveal truth or just artistic interpretations. After all, no one's returned from a real black hole to fact-check them. Are we seeing reality, or just best guesses wrapped in pretty pixels? The debate doesn't dampen the enthusiasm. If anything, it fuels more creative renderings. As you fall, you imagine students in classrooms touring a virtual horizon, giggling nervously as they lean into the digital void. You picture filmmakers layering accurate physics into science fiction movies, bending light convincingly so audiences glimpse something close to the real thing. Interstellar did exactly this, using equations from Kip Thorne to render its iconic wormhole and black hole scenes. It's funny, humans can't get anywhere near a black hole, but we've already built more than a few in our imaginations. Math fills in the gaps, computers polish the details, and suddenly, the impossible becomes a field trip. A joke slips through. If VR black holes become too realistic, future therapy sessions may begin with, "So, When did you first realize your fear of cosmic noodles? Yet beneath the humor lies a quiet truth. Simulations aren't just toys, they're rehearsal spaces for ideas. Every rendered horizon helps scientists refine predictions, check equations, and plan what to look for with telescopes. In a way, each simulation is humanity dipping a cautious toe into the abyss, practicing for journeys we may never physically take. And as you sink further into your own plunge, you realize the irony. While you fall for real, or at least in this story, thousands of people back on Earth are rehearsing this same descent in labs, classrooms, and VR headsets. They're exploring the same darkness, safe on the surface of a pale blue dot. You're all connected, simulations and reality blending into one long, curiosity-driven dive. The horizon swells, smooth and absolute. Whether simulated or real, the view is breathtaking, and you are right at the center of the show. The digital horizons dissolve in your mind, and another kind of image rises. Older, stranger, less mathematical. Long before Einstein's chalkboards or LEGO's chirps, people looked up at the night sky and told stories. They saw not equations, but gateways. And in those myths, you notice echoes of the very black holes you're falling into now. Ancient cultures often imagined the sky as layered, with pathways between worlds. The Greeks spoke of Hades beneath the earth and celestial realms above, connected by rivers and gates. The Maya envisioned the Xibalba Bee, a road of the underworld stretching through the Milky Way. In Norse mythology, Yggdrasil's branches linked 9 realms, and at its roots lurked the Well of Fate, deep and dark. You drift and realize all of these sound suspiciously like descriptions of cosmic doorways, not so different from wormholes or horizons, a historical anchor. The Dogon people of Mali told stories about a dense, invisible star orbiting Sirius, long before Western astronomy confirmed the existence of Sirius B, a faint white dwarf. While the connection is debated and sometimes sensationalized, it highlights how ancient traditions often wove unseen cosmic forces into their cosmologies. A quirky tidbit: in medieval Europe, comets were often seen as gateways themselves, harbingers not just of doom, but of transitions between realms. To imagine a comet as a portal isn't far from picturing a black hole as one. Perhaps humans have always sensed that the sky hides doors, even if we didn't know how to phrase it. Historians still argue whether myths about underworlds, tunnels, and celestial gates are subconscious echoes of real, astronomical phenomena, or simply metaphors born of imagination. Did people sense patterns in the stars or project their inner fears onto the heavens? The answer is probably both, but the resonance with modern black hole imagery is hard to ignore. As you descend, you picture those old storytellers gathered around fires, pointing at the Milky Way smeared across the sky. To them, it was the path of souls, a glowing river leading to other worlds. To you, it's the galaxy's backbone, at whose heart lies Sagittarius, a star. Same sky, different interpretations, same hunger to know what lies beyond. You smile at the thought, perhaps if you could whisper to those ancestors, "We've found the gates you imagined, and they're called black holes." They'd nod knowingly and reply, "Yes, we thought so." Here's a joke to soften the weight. If ancient myths were right, then your current fall means you're overdue to pay the ferryman. Hopefully you brought some cosmic pocket change. The parallels linger. Black holes as portals, horizons as thresholds, myths as warnings and promises. Even now, armed with equations and telescopes, humanity hasn't escaped the same pattern. We keep circling the idea that the universe hides doors we might one day step through. And as the horizon looms closer, you realize you're living the overlap, where myth meets physics, where gateways are no longer just fireside tales, but mathematical predictions bending the very starlight around you. The myths of gateways still cling to your mind, but here in the silence of the fall, another set of stories presses forward, less ancient, more eccentric. Fringe science, whispered speculations, late-night theories scribbled on whiteboards and forums alike. If black holes really are portals, what might be hiding inside? The answers people dream up range from the playful to the downright bizarre. Some fringe thinkers picture black holes as stargates, cosmic subway systems maintained by advanced civilizations. Why bother with rockets or warp drives when you can hop into a singularity and pop out across the galaxy? In these imaginings, aliens long ago mastered exotic matter, building highways through space-time. The black holes we see could be traffic hubs, their radiation nothing more than the exhaust of interstellar commuters. A historical curiosity. In the 1970s, physicist John Wheeler, who actually coined the term black hole, sometimes described them with metaphors that sounded suspiciously like gateways. Though he never claimed aliens were hiding inside, his playful language helped fuel a generation of sci-fi speculation. The line between serious theory and imaginative leaps was never as thick as we pretend. A quirky tidbit. Fringe writers sometimes suggest that black holes could contain entire civilizations, tucked safely inside regions we can't observe. Some even muse that aliens might create black holes deliberately, using them as power plants. After all, the energy output of matter falling in is staggeringly efficient, far better than any fusion reactor humans have dreamed of. Imagine a city powered by its own pet singularity, with a sign outside, "Caution, do not feed after midnight." Historians still argue where to draw the line between visionary speculation and pseudoscience. Is it irresponsible to imagine aliens building black holes, or does it spark useful thought experiments? The debates echo through academic halls and late-night coffee shops alike, unresolved but entertaining. You picture it now. Inside the event horizon, a grand alien metropolis shimmering in warped geometry, with creatures that treat tidal forces the way humans treat roller coasters. The idea is absurd, but also weirdly comforting. If survival inside a black hole is impossible for us, perhaps it isn't for someone else. You smirk. If interstellar tourists ever do use black holes as portals, then somewhere out there, an alien travel agent is warning. Avoid the smaller ones. They're rough on the spine. Still, the humour doesn't erase the intrigue. Fringe or not, these ideas remind you that black holes aren't just physics, they're canvases. We project onto them our fears, hopes, myths, and possibilities. Scientists scribble equations, dreamers scribble civilizations, and somewhere between, truth waits patiently. The horizon swells closer, smooth and unblinking, and you can almost imagine it winking back. Whether it hides aliens, stargates, or simply silence, you can't tell. But the speculation makes the plunge feel less lonely, like perhaps countless others, human and not, have wondered the same thing before stepping into the dark. The horizon fills your vision now, swallowing starlight, swallowing thought. It's no longer just a question of what lies beyond, but whether the word survival even applies. What does it mean to live through a black hole? Is it your body continuing intact, your atoms persisting, or is it enough if your information, your patterns, remain in some form? The question isn't just philosophical. Physicists wrestle with it too. If your atoms are stretched, shredded, or smeared across the event horizon, are you gone? Or does some version of you persist, encoded in Hawking radiation, plastered as a hologram on the horizon, or reborn in another universe's Big Bang? Depending on which theory you favour, you are either obliterated, preserved, or transformed. A historical note. In 1971, John Wheeler coined the phrase, "Black holes have no hair." The idea was that once you fall in, the black hole remembers nothing about you except your mass, charge, and spin. Everything else, the details that make you you, vanishes. It was a crisp, elegant slogan, but also a grim one. Individuality erased. Later, however, challenges to the no-hair theorem suggested subtle imprints might linger, encoded in the black hole's field. Even Wheeler's neatness may not hold. A quirky tidbit. Some fringe philosophers have half-joked that falling into a black hole might constitute a form of digital immortality. Your body is shredded, yes, but your information gets woven into space-time itself, etched into the cosmic record. The you that wakes up on the other side might not remember paying taxes, but technically, some version of your data persists. Comforting? Maybe. Creepy? Absolutely. Historians still argue whether survival should be defined biologically, physically, or informationally. Is a clone with your memories still you? Is a holographic imprint? Or does survival require your consciousness staying uninterrupted through the fall? The debates echo from philosophy departments to physics journals, unresolved and probably unresolvable. You ponder it as the horizon glows faintly ahead, bending galaxies into warped arcs. Maybe survival is a spectrum, not a binary. You may not walk away in the form that entered, but pieces of you, atoms, data, echoes, will persist somewhere. Perhaps that's enough. You can't help but laugh softly. Humans already practice a version of this. Every photo, every diary, every digital file is a crude hologram of your life, surviving after your body is gone. Maybe black holes are just the universe's high-end version of Dropbox. Still, the seriousness returns. To step through the horizon is to redefine survival itself. Will you emerge in another cosmos, be preserved as a hologram, scatter into radiation over eons, or simply stop? No theory agrees, and no traveller has ever returned to clarify. The pull deepens. The horizon looms, no longer a distant theory but a boundary brushing against your stretched fingers. Whatever survival means, you're about to test it firsthand. The last choice you face isn't whether you live, it's how you'll define what comes next. The horizon presses against your vision now, vast and seamless, the final threshold. All the theories, all the debates, all the whispered myths and simulations and jokes, all of them converge into this single moment. You hover at the brink, and the question that began your journey returns with sharp clarity. Are you ready to enter? Black holes have been painted as monsters, as portals, as engines of destruction, as wombs of new universes. They've been firewalls and wormholes, holograms and maternity wards. And yet, staring at the edge, you realize none of the arguments matter here. The horizon doesn't explain itself. It doesn't advertise wormhole shortcuts or flash warning signs of firewalls. It just waits. A historical anchor. When the Event Horizon Telescope collaboration released the first image of a black hole in 2019, astronomer Heino Falke described it not as a monster, but as a full stop at the end of space-time. That phrase lingers with you now. You're about to step into a period at the end of a sentence written over 13 billion years. A quirky tidbit. Some theorists suggest that if you could hover forever just outside a black hole, you'd see the universe race ahead to its end. In that sense, crossing the horizon isn't just entering the unknown, it's choosing not to watch the story finish. You're handing your ticket back to time itself and asking for a different seat. Historians still argue whether crossing the horizon is even meaningful. From your perspective, you slip through smoothly. From an outsider's, you freeze forever. Two stories, both true, neither complete. Perhaps that's the final trick. Survival, portals, information, they're all matters of perspective. What the horizon is depends on where you stand. You feel the tug stronger than ever now, no longer gentle but insistent, like a hand on your back urging you forward. Light bends into impossible shapes, spiraling into arcs that almost resemble doorways. Maybe they are, maybe they aren't. Wormhole, firewall, singularity, new universe. It's all conjecture. The only way to know is to fall. Here's one last joke for courage. If black holes really are portals, then this might be the universe's way of saying, next level unlocked, good luck with the tutorial. The horizon swallows the last of the starlight. You hover for a breath, stretched, warped, suspended between fear and wonder, and then, with no sound, no flare, no fanfare, you let yourself go. Whatever waits, obliteration, hologram, rebirth, silence, you're ready. Because sometimes the only answer to the universe's hardest question is the simplest step. You enter. The pull fades into stillness. You no longer need to picture stretching or collapsing or drifting through bent starlight. The horizon softens in your memory, its sharp edge dissolving into calm shadow. Everything slows, not like honey dripping, but like breath easing out after a long day. The theories, the paradoxes, the speculations, they quiet themselves, like distant voices closing a door. You find yourself floating in a vast calm, weightless and unhurried. No spaghettification, no debates about firewalls, no arguments over information, just the steady hush of space, as if the universe itself has dimmed the lights for you. Even the stars that once warped into arcs now glow gently, blurred into soft halos, less like equations and more like lanterns guiding you home. Your body relaxes, shoulders unclench, fingers soften. There is no need to hold on here. The questions you've carried about survival, portals and rebirth can rest. They are still there, but they no longer demand answers. They float, weightless, waiting, and you are free to let them drift. The silence isn't empty, it's soothing, like the low hum of a fan in a darkened room, steady and familiar. You sense the vastness beyond, but it feels friendly now, like an ocean that has stopped its crashing and settled into a tide. So you let your eyes close. The universe can argue and speculate tomorrow. For now, all you need is this moment of quiet, this gentle darkness that asks nothing of you but rest. Breathe in once more, let it go. You're safe, you're small, and that somehow feels infinite enough. End of script. Sweet dreams.